then finally, the last topic on reporting numerical data is on dimensional analysis. Earlier at the beginning of this study guide, we looked at converting metric units, which is amazing. All you got to do is move the decimal spot, piece of cake. Not so convenient if you want to convert English units. This method of dimensional analysis is priceless. At this point, that's really all I want you to grasp onto, this method of making unit conversions if you can't just move the decimal spot. And now, I get, in the lab, we're not going to measure in pounds or ounces, or we're not going to measure volume with pints and quarts. But it's this method of making unit conversions that I really want you to grasp onto at this point, because we're going to use this quite a bit throughout chemistry to make unit conversions of things that might feel a little more chemistry related. And if you grasp onto this method now, you can apply that to something that maybe you're not so familiar with, like atoms and molecules and all kinds of good things. I will always provide you with these conversion factors. This would be something that you do not need to memorize, not with the English units. Obviously, I should know the metric prefixes, kilo, hecto, deca, all that good stuff. You don't need to memorize that there are 16 ounces in a pound. I will give that to you on any test or quiz. Here's what we do want to be able to do. Perform a conversion using something called a proportion method. Okay, so we want to do these dimensional analysis calculations and show our work. And this is what's going to kill you. You got to show your work. Some people will be like, I can do this in my head. Okay, well then prove it. Then what did you do in your head? Did you multiply? Did you divide? Write it down. Because somehow you need to prove how you got the right answer. I start these off with the number that I'm given. There will always be some kind of a given number. So I have 185 grams. And then you set up times a proportion. When you do a unit conversion with this proportion method, the unit that you start with is going to go on the bottom. I don't want grams as my final answer. So by putting grams on the bottom, these units will eventually cancel each other out. The unit that you do want goes on the top. I want this in pounds. So pounds goes on the top. When I do this proportion method, I always put the units on the proportion first. Then I go back to that handy-dandy chart and I try to find a relationship between grams and pounds. And what do you know? 1 pound is 454 grams. So the 1 goes with the pound, and the 454 goes on the bottom with the gram. Done. Now here's what you're going to do in your calculator. Multiply across, divide by anything on the bottom. So essentially it's like 185 times 1 divided by 454. Oh. So do you kind of see then that the units cancel out? This is like grams times pounds divided by grams. Grams on the top, grams on the bottom, they cancel. Here's another nice thing. So I plug this in my calculator and I get tons of junk. My calculator screen is full. When you do dimensional analysis and you're ready to round, you can always round back to the number of significant figures in the given number. That 454 grams per 1 pound, it's considered kind of a constant. I personally did not measure that, but somebody probably measured that they had 185 grams. That was somehow measured in the lab. So we'll round back to the original measurement. So you just plug this in your calculator and you only have to leave the first 3 figures. So this was 1, 2, 3. So I'm just going to leave 0.407. Now, here's the problem. Some people are looking for a shortcut, and they can look up that conversion. They look it up first, so they know that 1 pound is 454 grams, and then they're like, now what? Do I multiply? Do I divide? Now what? What do I do? I don't know. It depends on what you want. What do you have? What do you want? That's why I like the proportion method. You don't have to try to memorize if you multiply or divide. Just set up the proportion. The unit that you want goes on the bottom. The unit that you have goes on the bottom so that it cancels. The unit that you want will go on top. Then you can put the numerical values in the proportion and see, oh yeah, I divide. Done. You can also see if your answer makes sense. 185 grams is a little bit less than half a pound. A pound should be 454 grams. Oh yeah, I mean it should be like less than 0.5. That makes sense, 0.4. So again, I take what I have. I have 13.6 liters, and I want to do a conversion with the proportion method. I don't want liters, so I'll put it on the bottom. It'll cancel. The unit that I want is quarts. I want that on top. Then I go to the chart and I find a relationship between quarts and liters. And I see, ooh, they're similar. 1.06 quarts is equivalent to 1 liter. So in my calculator, now I multiply. I'm going to go 13.6 times 1.06 divided by 1. Obviously, you don't have to plug that in your calculator. Liters on the top will cancel with liters on the bottom. So the only unit I have left is what I want, quarts. The first number has 3 significant figures, so I can just leave 3 in my final answer. I'm going to leave this as 14.4. And yes, that answer is reasonable. A quart is just a little bit bigger than a liter, so it should really be close to 13.6, just a little bit higher. No more memorizing. Do I multiply? Do I divide? And yeah, I mean, if you can do this in your head when it shows work, and when it says to show your work, at least write down whatever you plugged into your calculator so that I know how you got your final answer. And it wasn't that I just glanced at the person next to me or I took a shot in the dark. I don't know. You can string multiple proportions together. So for example, what if you have 23.6 feet? You want to set up a little proportion, and eventually we want to go to centimeters. But if you look on that chart, there is no conversion straight from feet to centimeters. So you look at what you have available. Okay, well I could go feet to inches and then inches to centimeter. Alright, so I want to cancel feet, and let's bring it to inches. Most of us probably know there are 12 inches in 1 foot. So now feet are gone, they cancel. If I plug this in my calculator right now, which I could, I would have an answer in inches. Or you can just keep stringing these proportions together. Let's do another one. We don't want our final answer in inches, so we're going to put inches on the bottom. The unit that I do want is centimeters. That goes on the top. And I do have a conversion. 2.54 centimeters for every 1 inch. Whenever you have a unit on the top and the same unit on the bottom, they'll cancel. To plug this in your calculator, you multiply by any numbers on the top and divide by any numbers on the bottom, which I really don't have to worry about if they're all ones. So I'm going to take 23.6 times 12 times 2.54. And my original number, again, by coincidence, they all have 3 sig figs. So I just round this to 3. Let's just say 719. 719 centimeters. There, done. This method is what I want you to grasp onto. Because again, I get that you can probably convert between like feet and inches in your head. But what if that becomes units that you're not so familiar with, like atoms and molecules and all that good stuff? Then you'll really want to grasp on to this proportion method. It is the most foolproof way I can think of for making unit conversions that aren't metric, where you can't just move a decimal spot. At this point, if you would like, you can try some more. There's a couple more practice ones in here, and I'll show you those in the next 2 videos. If you try a few and you feel like you're going to get them right, you could load the next video and just skip till the end and see if you are getting the correct answers. Maybe this is something that you've done in the past. If not, then you might want to watch the next 2 videos through to the end. Watch what you feel you need to feel like you have a good grasp of this concept of dimensional analysis, unit converting with a proportion method.